On this first problem, we start by finding this third side. Since this is a right triangle, we can use Pythagorean Theorem. So we know that 8 squared plus whatever this third side is squared equals 14 squared. So 8 squared is 64, and 14 squared is 196. So we end up with x squared is the square root of 132. Which, when we simplify, it turns into, that third side is 2 rad 33. So the length of this third side here is 2 rad 33. Our goal in this problem is to evaluate the 6 trigonometric functions for an angle theta. So here's theta right here, and relative to theta, this is the opposite side. I'm going to write opposite next to it. This is the adjacent side, and this is the hypotenuse. So sine of theta is opposite over hypotenuse. So that would be 2 rad 33 over 14. But the 2 and the 14 can cancel since they're both divisible by 2, and you're left with sine theta equals rad 33 over 7. Now cosine theta is adjacent over hypotenuse. So that's 8 over 14. That reduces to 4 over 7. Tangent theta is opposite over adjacent. So that's 2 rad 33 over 8, which will reduce to rad 33 over 4. The next 3 trigonometric functions are the reciprocals of these. So cosecant theta is going to be, instead of rad 33 over 7, it will be 7 over rad 33, the reciprocal. But there's a problem here because we have a radical in the denominator. We need to rationalize it. So if we multiply this by rad 33 over rad 33, we get 7 rad 33 over 33. The reciprocal of cosine is secant. So if we reciprocate this 4/7, we get 7 over 4. The reciprocal of this tangent one would be cotangent, and that would be 4 over rad 33, which once we rationalize, we get 4 rad 33 over 33. So these 6 answers here are the 6 values when we evaluate the trigonometric functions for theta. In this problem it says, let theta be an acute angle of a right triangle and find the values of the other 5 trigonometric functions. That's because we already have sine. So if we draw a triangle and we put theta in it, if sine is 5 over 13, we know the opposite side of theta is a 5, and we know the hypotenuse is 13. Using Pythagorean Theorem here, we know that 5 squared plus something squared equals 13 squared. So 25 plus something squared equals 169. If you subtract 25 from both sides, you get 144. So this side right here must be a 12. So this triangle is not drawn to scale, obviously. But with that, we can find cosine of theta, because now we have the adjacent side. Cosine of theta is 12 over 5, or 12 over 13, because it's adjacent over hypotenuse. Tangent theta is opposite over adjacent, so 5 over 12. Then the other trigonometric functions are the reciprocals. So the reciprocal of tangent is cotangent, and that's just going to be 12 over 5. The reciprocal of cosine is going to be secant, and that's 13 over 12. And finally, the reciprocal of sine is going to be cosecant, and that's just 13 over 5. On problem 3, we're trying to find the exact values of x and y. If this is 60 degrees, this is 30 degrees. And we know this relationship exists for a 30, 60, 90. X is the short side, and whatever this is, we're going to double it to get the hypotenuse. So maybe what I would do is, I'd leave this x here, but I would make this a 2x. There's no need for a y there, because whatever the short side is, we double it to get this side. Then whatever the short side is, we multiply it by rad 3 to get this side. So this down here is rad 3x. But rad 3 times x gives us 6. So if we divide both sides of our equation here by rad 3, we end up with x equals 6 rad 3. 6 over rad 3. Once we rationalize this, we get, let's see, if we multiply by rad 3 over rad 3, we get 6 rad 3 over 3. That reduces to 2 rad 3. So this side right here must be 2 rad 3. Since this is twice this side, this is 4 rad 3. So x is 2 rad 3, and y is 4 rad 3. This triangle is another special triangle. It's a 45, 45, 90. On a 45, 45, 90, our standard triangle is 1, 1, rad 2. So basically, whatever either of the legs are, if you multiply them by rad 2, you get the hypotenuse. Now, seeing our hypotenuse is 6 rad 2, we can figure out that each of these legs is just 6. So x and y both equal 6. On problem 5, we have to find a positive and negative coterminal angle with 5 pi over 3. So one thing to note here is 6 pi over 3, since it each equals 2 pi when you reduce it, that's actually a full rotation. So 5 pi over 3 would be about this much. That's 5 pi over 3. If you go another pi over 3, you'd be at 6 pi over 3, and that would be 2 pi, a full rotation. So if we're right here and we add another 6 pi over 3, in other words, we add another 2 pi, we'd be at 11 pi over 3. And 11 pi over 3 would be like going around another time, and you would be coterminal. So that's our first answer in radians. If we go the other way, if we're at 5 pi over 3 and we go this way, 6 pi over 3, in other words, we go this way 2 pi units, you'd be at negative pi over 3. It'd be equivalent to starting here and you go negative pi over 3. So both of these are coterminal. 5 pi over 3, if you convert to degrees, so if you multiply this by 180 over pi, the pi's would cancel, and you end up with, it's 300 degrees. So to get coterminal angles with 300 degrees, we can add 360 degrees. That gives us 660 degrees, which is equivalent to 11 pi over 3. Or if you take your 300 degrees and instead subtract 360 degrees from it, you get negative 60 degrees. And that's the negative pi over 3. On the next problem, we're going to use the point negative 1, negative 2 to be on the terminal side at angle theta in standard position, and we'll evaluate the 6 trigonometric functions from that. So negative 1, negative 2 would be about right here. So the angle we're interested in is this. This is theta, that angle. But what's interesting is the coordinates of this point are negative 1, negative 2. If we draw a right triangle and we realize that these coordinates actually tell us the side lengths, here's what we find. If the y coordinate is -2, that means this side must be 2, since we've dropped 2 down from the x-axis. If the x coordinate's -1, that means we're 1 unit over, so this must be 1. So knowing this is a right triangle, we could figure out what the hypotenuse is. 1 squared plus 2 squared would have to equal the hypotenuse squared here. So 1 squared, but this would be 5. So this hypotenuse here would have to be rad 5. We actually don't call this a hypotenuse in this case, we call it the radius. So I'm going to change my h to an r there. So the radius is rad 5. Now here's what we have. X is -1, y is -2, and the radius is rad 5. Using our circle definitions for trigonometric functions, for example, we know sine theta is y over r. So in this case, it's -2 over rad 5, which after we rationalize is -2 rad 5 over 5. Cosine of theta is going to be x over r. So it's, after rationalizing, going to be -rad 5 over 2. Tangent is y over r, so it's -2 over -1, so it's 2. And then the reciprocal functions. Cosecant theta is going to be the reciprocal of this, so it will be -rad 5 over 2. Secant theta is the reciprocal of this, which after we rationalize will be -rad 5. And the reciprocal of 2 would be 1/2. On this next one, we have to evaluate -120 without a calculator. -120 degrees, so if we start here and rotate down to this first axis, that's -90. Going another 30 degrees would get us to -120. The reference angle here is 60 degrees. And the reference angle is always drawn to the x-axis. So the angle between this and this is 60 degrees. We know that because if we're already at 120 degrees, we'd need another 60 to get to the 180. If we complete this triangle, we see it's a 30, 60, 90 triangle. And the length of this side would be rad 3, the length of this side would be 1, and the radius here would be 2. That's from properties of 30, 60, 90 triangles. So the coordinates of this point would be -1, -rad 3. Now we know that sine theta is y over r, so the y coordinate is -rad 3, and the radius is 2. So sine of -120 is -rad 3 over 2. To find cosine without a calculator, well, we're doing something different here. This is inverse cosine of 1/2. So with inverse cosine, you're given the ratio of the sides and you're trying to find the angle. So what this is asking is, what angle does cosine produce 1/2 for? I recognize this 1 and this 2 from the 30, 60, 90 triangle. On a 30, 60, 90 triangle, the short side is 1, the hypotenuse is 2, and the long leg is rad 3. So since cosine is adjacent over hypotenuse, we need to find the angle that has an adjacent side of 1 and a hypotenuse of 2. 60 degrees has an adjacent side of 1 and a hypotenuse of 2. So our answer is 60 degrees. There's two ways to look at problem 9. We're trying to find what angle causes tangent to equal 1? So if you think of tangent as the opposite over the adjacent side, you could think of when is the opposite and adjacent side the same value? Well, in a 45, 45, 90 triangle, if theta is right here, one of the 45s for example, both the opposite side and the adjacent side are the same value. So the answer here would be theta equals 45 degrees. Or if you're using the circle definition, you're trying to figure out when are the x and y coordinate exactly the same. So if you start here at 0 degrees and you start to rotate up, think of all the xy coordinates along this line, or along this sector of a circle. Right when you get halfway in the quadrant, the x coordinate and the y coordinate would be the same value, since we're equidistant from the x and the y axis. On problem 10, we're told that sine of some angle equals negative 0.72. So if you use inverse sine of that negative 0.72, you can figure out what theta is. So let's try that. We get negative 46 approximately. So theta is approximately negative 46. So negative 46 degrees would be right here. And the only other requirement in this problem is we want an angle between 270 and 360 degrees. Here's 270 degrees, here's 360 degrees. So if instead of going negative 46 degrees that way, if we go all the way around this way, we'll have an angle between 270 and 360. So to figure out what that angle is, take your 360, which would be a full rotation, and subtract out this 46 here. Actually, we can just add 360 to what we had there. So we get, there's our exact answer. So it turns out theta is about 314 degrees, which notice this is between the 270 and the 360. On the back, our first problem is to find the height of this tree here. So we have 31 degrees here, and we're interested in the opposite side, the side that's opposite the 31. And we already know the adjacent side is 25. So since we're dealing with opposite and adjacent, we can use tangent. Tangent of 31 degrees is the height of the tree we're trying to find over the adjacent side. If we multiply, we're trying to solve for h here, so if we multiply both sides by 25, 25 times tangent of 31 degrees will be the height we're looking for. So we need a calculator to do that. 25 times tangent 31 degrees. So it appears the tree is about 15 feet tall. On this problem, let's start by converting theta into degrees. So pi over 2, if we multiply by 180 over pi, the pi's would cancel, and 180 divided by 2 is 90 degrees. So we're interested in what is the value of the 6 trigonometric functions at 90 degrees. So if we start here with a little radius of size 1, and we rotate that up 90 degrees, so the length of this radius here is 1, and we're interested in what are the coordinates of this point here. So we have the x-coordinate would be 0, and the y-coordinate would be 1. So here's what we have. X is 0, y is 1, and our radius is 1. So the circle definitions our sine theta is x is y over r. So in this case, it's 1 over 1. Cosine theta is x over r. So in this case, it's 0 over 1. So that's just 0. Tangent theta is y over x, which is 1 over 0. So it's undefined because 0 is in the denominator. Cosecant is the reciprocal of sine, so it's r over y, which is 1 over 1 again. Secant is the reciprocal of cosine, so it's r over x, which is going to now put the 0 that was the x into the denominator. So this is going to be undefined. And cotangent is the reciprocal of tangent, so it's going to be x over y, which is 0 over 1. It's going to be 0. On problem 13, it says sketch the angle, then find its reference angle. An easy way to do this might be to first convert it into degrees. So to convert it to degrees, we multiply it by 180 over pi. So the pi's cancel. 180 divided by 3 is 60, and 8 times 60 is 480 degrees. So 480 degrees would mean if you start here, you're at 90, 180, 270, 360. 360 plus 90 is 450, so it's 30 more degrees past that axis there. And the way we would sketch this is we'd show we went all the way around once and then a little bit more. So that's 480 degrees. The reference angle is the quickest way to the x-axis. So from here, the quickest way would be to go down to the x-axis, not to go all the way back. If you went back, you'd be going 120 degrees. If you go forward, it's 60 degrees. So the reference angle is 60 degrees. However, since it started the problem in radians, we should probably convert this back into radians. So in radians, 60 degrees is pi over 3. On this problem, we're not going to use a calculator, but we're going to try to figure out when is cosine theta equal to 0? What angle causes it to be 0? And in particular, what angle that's between 0 and 180 degrees causes cosine to be 0? So we know that cosine of theta equals the adjacent side over the hypotenuse. However, to get an adjacent side of 0, we're not dealing with a triangle. So this isn't really the right definition to use. If you use the circle definition of cosine, it equals x over r. This might work because if we can get an x value, for example, of 0, so an x coordinate that's 0 and a radius is always 1 in these examples, we'll have the angle we're looking for. So if we look at each of the axes, if the radius is 1, the coordinates of this point down here, for example, would be 0, negative 1. Up here would be 0, positive 1. Over here, 1 unit over would be negative 1, 0, and this would be 1, 0. So let's see. The x-coordinate is 0 both at 90 degrees, right there, and at 270 degrees. However, only 90 degrees is between 0 and 180 degrees. So the theta value we're looking for is 90 degrees because the x would be 0 and the radius would be 1. Here, we're told an escalator ascends 45 feet over a horizontal distance of 30 feet. So ascends means go up. So it goes up 45 feet over a horizontal distance of 30 feet. And we're trying to figure out what's the angle of elevation. The angle of elevation is this angle right here. So we're trying to figure out what theta value would cause this triangle to exist. So since we're dealing with the opposite and adjacent side, we know that tangent theta has to equal 45 over 30, which we can reduce to 3 over 2. To do this on the calculator, we evaluate inverse tangent of 3 over 2, and that will give us the value of theta. So inverse tangent, which you can get by pushing shift, and then tangent, and 3 over 2. 3 over 2 is that. Turns out that angle is about 56.3 degrees. On the last problem here, a stepladder has an angle of elevation of 60 degrees with the front of the house. The length of the stepladder is 24 feet. So here's a house. Here's a stepladder. And we know this stepladder here is 24 feet long. And we know the angle of elevation is 60 degrees. And what it's saying is, at what height does the stepladder meet the house? So here's the house. We're trying to figure out what this height is. Well, this happens to be a 30, 60, 90 triangle. So if this is 24, then this side would be 12, the short side. It'd be half the hypotenuse. To get from this side to this side, we multiply the short side by rad 3. So the height would equal 12 rad 3.